There's a very important graph in computer programming. And this graph was true the first time a program was written, and it's true today. Yes?
No.
Okay. I'm like an auctioneer. If I see someone move a little bit, I assume they're asking a question. The graph looks like this. And the graph, the general shape of the graph says this. The further along you are in a programming process, the more expensive it is to make a change. So, if you're thinking about writing a program, maybe you're sketching something out on paper and talking to people about what the website needs and that sort of stuff. If something changes at that point, it's not that expensive to make a change. You know, you're only talking about drawings on paper maybe. So you can erase and redo it. All right? If you started doing a little bit of coding, well, the expense to make the change goes up a little bit. If you are in the testing phase, the expense goes up a little bit more. If you are in the deployment phase, then the expense goes up even more. And then finally, if you've implemented the program and you discover that there's something you forgot or that there's something that needs drastically changed, then the expenses go up even more. So what's important is that this graph increases the further down line in the process you get. And that should sort of make sense to you because that's probably the true about every process, right? If, for example, you're making a cake and you put, the cake calls for 3 eggs and you accidentally put 2 in, then you remember that at the last minute and say, ooh, it needs another egg. If the cake is still, you're still mixing up the batter.
Attention please. At 8:28 a.m., the North Tower of the World Trade Center collapses. The attacks of September 11th, 2001 kill 2,977 people.
I think he meant 10:28, but because they were going on. Someone I know was telling me they were announcing the events in real time as they've happened. At any rate, if you're making the cake and you're still in the batter stage, right? If you're thinking about making the cake and you haven't put the 3rd egg in, that really doesn't matter, right? But if you're at the batter stage, let's say, you started mixing the batter and you realize, oh, I forgot an egg. It's no big deal to put it in. If you put it in the oven, well, that becomes harder to change. If the cake is actually finished, it becomes really hard to change. You probably have to scrap the cake if that's a big enough deal and start all over again. All right? Building a house is the same way. If you decide, if you're sketching up a house of what your dream house looks like and you want a room that is 10 feet by 10 feet, then you say, no, I really want this room to be big. I want it to be 16 by 16. Well, when you're still a drawing on an architect's, blueprints, might cost you some to make it bigger, but it's not the same as when you've moved into the house and, your life is going on in there. There's a greater cost. There's a greater difficulty, a greater cost. So I think with most things, when you're planning them and when you've started the work, making changes is relatively easy. When you are finished with it, making changes is relatively hard. And that's what this graph says. So there's a couple of ideas about this. First of all, notice that the graph is increasing. This graph will always increase. There's never going to be a day that after you finish the program, it's going to be cheaper to make changes than when you started out. It just doesn't even make sense. The other thing is, notice that this is sort of an exponential increase. It's not simply a linear increase. It's not like it increases like that, where it gets a little more, a little more, a little more. It increases at an increasing rate. Those of you taking calculus, this has a positive first derivative. So it's increasing at an increasing rate. All right? And that's also characteristic of this. So here's the bottom line. We're never going to be able to make it to where it's flat. But if we apply some good programming practices, we can flatten out this curve a little bit. So maybe for a poor developer, or let's do this. Maybe for an average developer, the graph looks like this. Maybe for a poor developer, the graph looks like this. Maybe for a great developer, the graph looks like this. So it's never going to be flat, all right? It's never going to even be a line. But a good programmer, someone that applies good programming techniques, can flatten it out a little bit. So that's why we stress all these things of making your code a certain way. All right? And one of them is avoiding having duplicated code. All right. So let's look at that with respect to what we have here today. And let's spend a minute reviewing it before we talk about the duplication aspect of it. So I'm going to go open up this application in Visual Studio. Turn on my Solution Explorer. I want to look at the code for a minute. There's the code. Think it works? Let's run it and try it. Alright, I picked low, I rolled, and I lost. That's correct. We talked about the difficulty of testing this. Alright. Because there's randomization built into it. Alright, but seems like it works. We talked about setting breakpoints if something didn't work. If I had a piece of code wrong, we could go and do that. So this code works. It got the job done. Now, simply coding a solution that works doesn't make for good code, though. All right? If I was grading this, a solution that works is sort of the starting point for talking about good code. It's not the ending point. Other considerations, mainly, are the maintainability. How easy would it be to make a change? How easy would it be to do the same thing in a different place? And so on. Those are key questions as far as this. How reusable is our solution? All those things are factors that come into play. So if your code works, that doesn't mean that you did a great job. That means that you probably did an adequate job. Okay? So what we're going to do now is we're going to look to see how we can elevate this and make this better. All right? So let's pretend I have to play this game at a different place on this page. I know that's a little far far-fetched, right? I mean, it doesn't really make sense for me to have two versions of the game on the same page. But let's think beyond this specific problem, all right? Because there might be occasion where we would do the same thing twice on a page, like if we had a shipping calculation. Maybe we showed options for products. You have product A that you want to ship overnight, and it would cost $50. You have product B that you want to ship overnight, it will cost $75, and so on down the line. So maybe we want to do that shipping calculation several times on the page. So yeah, admittedly, in this case, it's doubtful that we'd ever want to have one page have two versions of this game on. But again, think beyond this specific example to any sort of algorithm or function that you'd want to do a couple times on a page. All right? We would want to have the ability, or we would like the ability, to be able to do this with minimal changes. All right? Right now, if we look, this code is tied to the button. It's tied to the button. Sometimes it's called coupled. All right? It's tied to the button. In other words, the code executes when you click the button. What happens if we want the code to execute under other circumstances? We're out of luck. All right? Because this code only runs when that button is clicked. So if we want that code to run when some other button gets clicked, we're out of luck. All right? The code is tied to those specific images. So if we had another set of images on the page, we'd be out of luck. The code is tied to that drop-down. So if we had a different drop-down on the page, or maybe we had radio buttons on the page, where you could play the game with radio buttons, then this code wouldn't work. Finally, the results are tied to that label. What if we wanted to show the results a different way? Again, out of luck. So this code is very tightly bound with the user interface, right? The user interface being all the stuff that's on the page. The button, the images, the labels, the drop-down. First thing that we want to do, I'll give you another example of this. Let's say I wanted to have a button that simulated what happens if I pick 7 1,000 times. All right? Or what happens if I randomly pick between low, high, and 7, and I ran it 1,000 times? How much would I expect to win or lose? Well, again, that would involve maybe another button down here that says go ahead and run 1,000 simulated games, where we'd have to go and run a game over and over and over again. But we hadn't clicked that button. We've clicked another button. So our goal, first off, is to move that code out of that button and put it somewhere else on the page. Okay? And then, what we're going to do is we are going to take it even further and take this code out of this page and put it somewhere else. Okay. Trying to think of what I want to do next. Maybe I want to skip that second step. any value of going it over. That really isn't going to buy us much if we put the code elsewhere on this page. All right. I'm going to create my own class for it. Creating my own class is like creating my component, which means like creating my own component, which means I can put this on any page. So I could put it twice on this page if I want to. I could put it on a second page if I wanted to. And we'll go and actually do that. All right. Well, actually, when we're done, we'll create a second page to do that. All right. In fact, let's go and create that second page now. All right. Let's go and create that second page now. That is going to look a lot different than this. It's going to have a radio button instead of a drop down. And it's not going to have pictures of dice. It's just going to say you rolled a 1, you rolled a 6, total is 7, you won. Okay? So we'll go and we'll do that. We'll create a second page that has this code on. So I'll call it default 2, place code in a separate file, Visual C#. We'll go here and I'm going to put a radio button list on my page, edit items, my button here. We have 3 labels. Labels are called label 1, 2, and 3. Cleverly enough, I'll just leave them like that. All right. Then I'm going to put a label 4 for the results. So I'm going to copy this code. Because a lot of the code's going to be the same. But it's going to be different. It's not going to be really duplicated code, but it kind of is, right? Like, it's not going to like exactly match up, but it pretty much matches up. So I'll go in here, double click on the button, paste this code in here. I have to do some changes. I don't have an image, so I have to get rid of this line of code. But I do have a label. Label 1 dot text equals value 1 to string. All right, I don't have a label for this one. So I'll put that there. Sum is still the same. I want to put in label 3, the value of the total. I don't have a drop down, but I have a radio button list 1. selected value. Okay, that works. Equals low. What did I call these guys in here? High, low, and 7. So if radio button list 1 is selected value is low, I will put in label 4 that they're a winner. I hope you're getting a sense of how tedious this is. It's a pain, right? I'm dreading this, and I know that I'm doing it that way for a demonstration. Okay, so this should be right. All right, let's go and run it.
In front of some of dice, label should be 3.
Repeat that, please.
In front of some of dice, go up. I believe label should be 3.
You're right. It actually would have been good if we let that error go through, because that would have further showed what a pain this is. All right? Build fail. Let's see what the error message is. Set problems at line 60. Oh, I think I'm missing one of them. I have an extra one of them. All right. High, 7, 6, 4 winner. Okay, good. 7, 2, 1, 3 lost. Okay, so that was a pain to do that, right? And what if I wanted to change the words winner and lost to something else? You have won, you have lost, all right? I would have to do that in a couple different places, right? And what if I had to make any change? I would have to make what if I changed this game so that I rolled with 3 dice and I had different rules to it, all right? I would have to go and make the change in 2 different places. You add this to 3 pages, 3 places, and so on and so forth, all right? So I think you get a sense of the problem that we're dealing with here. When you have duplicated code, first of all, you're more prone to make mistakes, right? Someone noticed that I had the label wrong, but that could easily went by, and I would have a bug, and I would have to find it. Now, to be sure, that kind of bug really isn't that hard to find. But in a more complicated algorithm, a more complicated process, that could have been a difficult bug to find. and we would be staring at it simply because we copied and pasted wrong. All right? And that could be a problem. In addition, just copying and pasting and making the changes was relatively time consuming. It took 10 minutes maybe. If there were more, it would take more. All right? So it would be nice if this code lived only in one place, is the bottom line. Essentially what I want is I want a component that I can plug into my page and say, I want to play the high-low game. And I just want to write the user interface for it, but I want all the game logic in one place. All right? That's known in object-oriented terms as encapsulation. All the logic about something lives in one place. All right? Now, those of you that take Java or have taken Java or advanced C# will cover this in great detail, but I do want to talk about how this works within this context. So I want to do a simple case of this, okay, and define a class that contains everything about the game, all right, and is tied to a user interface, and all the logic is going to be in the class, all right? So, a class is a representation sort of an entity that exists in your problem. All right? In this case, I would say there are two classes that we're going to create. What do you think the two classes we're going to create are? Go ahead.
The input and the output.
The input and the output? That would be how we interface with the classes, but those are not the classes itself.
Two ways of doing it.
No, because there could be 3 or 4 ways of doing it.
Oh.
We actually have two entities from a software perspective here. We have the rules of this game, all right, and then we have the dice. Now, we might write another page. This is sort of a real concern. We might write another page that has a different game, dice game, right, that has Yahtzee, all right? The dice of high-low and the dice of Yahtzee are the same dice, right? They do the same things, right? What do we do with the dice? What can we do with the dice? Really only one thing, right? We can roll the dice, all right? We can also, in object-oriented terms, ask the dice what your value is. All right, we can say, hey, what's the value of this dice? And it's going to be a 1 through a 6. We can also ask what the image for the dice is. All right, so we're going to create a class, and we're going to do this piece by piece. All right, the first thing we're going to do is we're going to create a class for the dice. When we create a class, we're creating a template for every dice in the world. And in our case, every dice in the world, there's a few things that the dice knows, and there's a few things that we can ask the dice. We can ask the dice to roll. All right, so we can roll the dice. Rolling the dice does what? It randomly picks from the 6 sides. All right. We can then ask the dice, what is the value of the dice? What's the value that's showing? Finally, we can have the dice tell what the image is. So give us the image that's related to your value. In object-oriented terms, classes have attributes and methods. Attributes are characteristics. Methods are where you take those attributes and do some things with them. Like, for example, rolling the dice randomly selects the value for the dice. So I'm going to go up here. I'm going to say File, New, File. Class. And I'm going to give it a name. Here, like name is meaningful. So I'm going to call it dice. I'm going to click add. It will tell us it wants to put it in a certain folder, that it's better if we put it in that certain folder, and we're going to say okay. So it has created that dice class in this folder. I'm going to start by putting the attributes for the dice. And we said that a dice only has one attribute, and that is the value of the dice. I'm going to make it a private field. A private field means it can only be accessed within this class. No other code can look inside the dice and see what the value is. All right? That's a good thing to do. You know why? Because we don't want programs manipulating this. Like, we don't want some unscrupulous programmer to load the dice and to set the dice to a certain value without rolling the dice. So we're going to make it where the only way that you can roll this dice is by calling the roll method on the dice. So we're going to create a method or a function called roll. This thing we want to be public. Public. What does it return? It returns an integer. What is the name of the function? Roll. And it accepts an argument. I think it's just complaining that it's lowercase. Okay. So, how do we roll the dice? Well, we have that snippet of code in here, right? We set the value to a random value. Oops. And then finally, we have to return that value. So, I have a method or a function on the dice object that's called roll. What does it do? It randomly assigns a value of the dice to a value between 1 and 6, and then it reports back what I rolled. So who wants to be a dice object? You're not actually going to change it to a piece of code, okay? You're just going to pretend to be a dice object. So who wants to play the role of a dice object? Okay, you're a dice object. What I'm going to do is I'm going to ask you to do a method, and you will report the result back. Now, for the random number generator, just pick a number between 1 and 6. So if I say roll, what do you return?
5.
If I say roll, what do you return?
1.
Okay. See how that works? I, who in this place am sort of playing the role of the user interface, I have an object, a dice object. I ask that dice object to roll, and it tells me the return value, because that's what the return value is. The return value is where the function tells whoever called it what the answer is. So the result of rolling it. Now, I'm going to put a couple more functions in here that might not be obvious at first. I shouldn't have to roll it to find out the value of it. I should be able to simply ask it what the value is. So, you're still a dice object. Alright? Roll.
2.
Okay. I'm going about doing some things. I'm sorry, what was your value again?
2.
Okay, see there? I rolled it. It randomly set the value. It still has that value. And if I ask it again, oh yeah, what's your value? It returns that value. Alright, the last thing I'm going to do is I'm going to create a method that returns a string. And that string is going to be the name of the image that represents that dice. And I don't have an image on that page. The image name is simply the string that consists of images, because that's the folder that they live in, /D, because all the images start with D, right? There's the image folder. All the images for the different dice start with D. Then the value of the dice, so if it has a value of 1, the image is images/d1.png. So I'm concatenating these strings together to give me the image that corresponds to that dice. So, I haven't rolled you again. So what's your value? Get value?
2.
What's the name of your image?
D2.
Okay. To be complete, it's images/d2.png. So it gave me the images. So what I've done is I've taken everything that's important about a dice and put it in this class. Now, guess what? I can make 1 dice, 2 dice, 1,000,000 dice. So I have this code in a class now. I can write all kinds of dice games. And I don't have to duplicate this code. I have the code to roll the dice, I have the code to get the value, and I have a code to get the image name. This is nice because anyone else writing a game doesn't have to go and do this. Is this a lot of code? No. But the more you have to do something repetitively, the more likely you are to make a mistake. Alright? So if I can give you a component that says, this is my dice. Alright? If you want a dice on your page, use this. And this is how you use it. You can roll it to get the value of it. You can ask what the value was again, in case you forgot. And then finally, you can ask for the image name. That's a big win. I've extended the .NET framework, right? The .NET framework already has a bunch of different classes for the user interface things, right? There's a class for the calendar that we just use if we want a calendar. And we don't really have to do anything terribly fancy to it. All the behavior for a calendar is built into it. Likewise, there's classes for validators. If we want to use it, we just pop one on our page and set some parameters for it. Now we've made our own custom class for something that's in the problem domain. Our problem domain is playing games. Dice is something that's in a problem game. So if we wanted to build a Monopoly game, we could use this dice class. If we wanted to play Yahtzee, we could use this dice class. Any dice game, this should cover the behavior of a regular 6-sided dice. Okay, so now I'm going to go and change both of these to use my dice class. So, first thing we're going to do is I'm going to create 2 dice. All right. That's how we create an object. What's the difference between a class and an object? When a class and an object, we're defining sort of a template. And we say all members of this class have these certain characteristics, have these certain behaviors. When we create an object, we are creating a member of that class. So we're creating one actual dice that we can roll. Put differently, bottle of pop might be a class, and it would have everything that we're interested in about a bottle of pop. The size, the manufacturer, the flavor, how many calories, and so on. This would represent one object, because it's one instance of that class. The general class is bottle of pop. This is one specific bottle of pop. All right? So, the dice class is representative of all the dice in the world. We're making 2 of them to use in our game. So, once I do that, I can get rid of some code here. I'm rolling the first dice by saying D1, that's the name of the first dice, roll. So I'm calling that function on that dice object. Image 1 dice equals, well, I'm asking the dice for the image name. I roll the dice 2, and I ask dice 2 for the image name. Sum of dice equals value 1 plus value 2. All right. I've taken out all the code in here that was code about the dice, and I've replaced it with my custom class. And I can do the same thing for this guy. So now, I go and run this. Either one of these pages uses my new dice class. You know something weird here? It's always rolling doubles. So, I think that can be fixed by putting this up here.
6 or 7 is supposed to be in the random.
Okay, still rolling doubles.
Is that 7 the next public endpoint?
Pardon me?
Is it 1 and 7 or 1 and 6?
1 and 7, because 1 and 7 returns a value from 1 to 6. So it goes almost up to 7.
Oh, okay.
Is it returning the, when you call the roll method, is it only returning the value? Like you have the one random and then you roll and return the value, so it's returning that value twice?
It is the way, it's a quirk in the way that the random works. So I'm going to make this a static variable, and let's see if that matters. That should fix it. Yeah, there we go. Okay. A static variable means that there is just one value per class. A random number generator is actually not random. It's what's called pseudo-random. And it's sort of complicated how it works. But in a nutshell, if you create a random object and call the random function over and over again, you actually get a constant series of numbers that gets seeded by the time, I think. So if you ran a couple instances of it. But the idea is if I make a static one, then I'm always getting the next number on the list, because static means that there's only one of these that exists per class, as opposed to one of them per object. So I'm always using the same random object, so I am not going to get repeated numbers. Whereas if I use 2 different random objects and call them, I'll get the same number sequence always. All right? Okay, so we fixed that. Bottom line is if you're going to do randomization like this, put static before that. And actually I'm going to put private static before that. Okay. Now this doesn't look like much, right? This doesn't look like much of a victory. But we've done a couple of things. That quirk about the way the random number is generated. If someone missed that, they're liable to always write their code to return doubles. Or can you imagine if this bug existed in a Yahtzee program? Everyone would roll Yahtzee every time, all right? Which wouldn't be a good thing. So there's one place where the dice code lives now, and I can use that. Now you might say there's still a little bit of duplicated code, right? Because here I say create a new dice, create a new dice. Here I say D1 roll, D1 roll. But it's simple code that's duplicated. It's simply calling a function on a class. It's not actual, like, processing code that actually does the job. It's asking the dice to do the job. It's not doing the job itself. So even though it's a modest win, that's actually a win. My next step is going to be a bigger win. Because what I'm actually going to do is I'm going to create a class to represent the game rules. Okay, let's ask for volunteers. All right, who wants to be a dice? Okay, we have one dice. Who wants to be another dice? Okay, so we have 2 dices. Your dice 1, your dice 2. Okay, who wants to be the rule master? I'll give it a flashy sounding name so it sounds like it's important. Who wants to be the rule master general? Oh, you came close to raising your hand. Okay, there you go. And I'll be the user interface. All right. We're going to communicate in a very specific way. All right? I'm only going to talk to the game. All right, to the rule master. The rule master can talk to each of the two dices. I'm only going to call function names. All right? And I'm going to give inputs to it. So for example, I'm going to say, if I were to say, play the game and tell me if I won or lost, what piece of information would you need? You need to know the two values of the dice. What else would you need?
The rules of what constitutes a
You
winner
need to
loss.
you need to know the rules. And what other piece of input would you need? You need to know what my selection was. So here's how it's going to work. I'm going to say, play, I pick low. You're going to do everything that you have to do to play this game, and you're going to give me the results. And you're going to say, you won, you lost. That's all you're going to tell me. All right? When I say, because a function can only return one thing. So our function is going to return a Boolean. A Boolean is simply true or false. True means you win, false means you lose. So, if I say, play high, what are you going to do to figure out if I won?
Request a roll from each dice.
Okay, so go ahead, ask dice 1.
Dice 1 roll.
5.
Okay,
Dice 2 roll.
4.
And you said high?
Yes.
Said winner.
okay, winner. See how that works? He is asking each of the dice, because each of the dice is like the boss of themselves, right? They know everything about everything that a dice can do. All right? So they can ask, you can ask it to roll. All right? Now, I might say, give me the image for dice 1.
Dice 1 get value? Get value, right?
Okay, so you'd ask the dice to give you your image.
Okay. Get image?
Yeah, you'd ask
Okay.
dice 1 to give you image.
Okay.
No, you're not rolling. You still have the same value.
I'm still 5.
So the image would be images/d5.png. And ask him for his image.
Roll dice 2 image.
Images D4.
Okay, so that's all I'm going to do. My user interface is going to give you my choice, whether I won or lost. And you're going to tell me whether I won or lost. I'm going to then ask you for the images, if I want the images. Or I might ask you for the value. What was the value of dice 1?
Dice 1 get value.
Okay, haven't rolled yet, so still 5.
4.
Okay, so that's what we're going to write in code. We're going to simulate that process. So I'm going to create another object. And I'm going to call it high-low game. Okay. High-low game has what? Has 2 dice, right? So we're going to make the dice over here. Interesting thing is, the user interface doesn't even need to know this is a dice game, right? Because it's not going to have anything to do with the dice. It's going to ask the game to do its thing. Dice 2 equals dice. Public, because it's a public function. Boolean, this returns a Boolean. Play. And I'm going to give a string which represents the user's choice. An argument, right? Because it's not enough for me to say play. Tell me if I won or lost. I have to say play, and oh yeah, I picked high, or I picked low. So, what's going to happen? Int v1 equals d1.roll. Int v2 equals d2 roll. int total equals what? v1 plus v2. Now, here's why my if statement. I'm going to copy this code here. On that page, I was getting a value from the radio button. Here, where am I getting the value of the user's choice? From the argument. So if the R choice equals low, and the sum of the dice, which I've called total, is less than 7, then my result equals true. I have won. I'm going to declare Boolean for result up here. Otherwise, my Boolean is false. If I chose a 7, and again, this is written independent of the user interface, right? So I can use it with any user interface. So if the argument is 7 and it's equal to 7, then I've won. Otherwise, I've lost. Finally, if our choice equals high, B result equals true, result equals false. Sum of dice, that should be total. And when all is said and done, I'm going to return B result. Okay, I'm going to add 2 more functions in here. How do I know what the image is associated with dice 1? I ask it. Dice 1, what is your and I return it. Dice 2. What is your image name? Finally, I have the same thing for their values. I want to get this completed at the end of class today. We will review this in more detail on Thursday. least convert one of these pages to use the game object completely. So let's convert this one. Watch what I can get rid of. Where is my option coming from here? It's coming from DD selection. And get rid of all this code. Because all that code now lives in my class. So, I can say string user choice equals the value from the dropdown. I can say high-low gain H equals new high-low gain. I'm creating my game from the template of games. I can say if h.play user choice LBL results equals dot text.
Have an awesome class.
Oh, thank you.
You're welcome.
Text equals winner. Else LBL equals loser. Only the other thing I have to do is I have to ask this for the images. So, image 1 what do I call those images? AMG Dice 1, there I go. IMG Dice 1 dot image URL equals h1 get image dice 1 Now notice a couple things. First of all, a lot less code here in the button play, right? We've cut it down from being 20 lines of code to being maybe 8. Also notice it's simpler code. It's just calling functions on my classes. It's not doing the actual random generation and this, that, and the other. It's simply calling functions on classes that we've already defined. So let's make sure this works. All right, I'd hate to declare victory so quick, all right, if it doesn't work. So let's make sure that it works. So I'll run this. And I'll make my selection low, play, I won. I picked 7 and it took, oh, I thought it was a 5 and a 3. I'm seeing things this morning. I'll pick 8. Okay, I lost. Looks to me like it's sort of still working. All right. Would obviously want to do more tests before we were happy with it. So, notice what we've done. We've taken all of the game logic, all of the business logic, and put it out somewhere else. We can now use those components anywhere we need them. So if we need another dice game, guess what? If we want to play Yahtzee, we create a Yahtzee class. That Yahtzee class, instead of having 2 dice, has 5 dices. And asks each one of them to roll itself when you start playing. All right? And so on and so forth. Monopoly, we do the same thing. We create a pair of dice. All right? And we roll it and we do the related thing. All right. Next time, I know I kind of rushed to get through this. Next time we'll look at this in more detail. In addition to the details of the code and how it works the way that it does, I want you to understand the rationale behind the code. Why we do this. All right? Why wasn't it enough just to have what we had before? All right? And then I'll go and I'll convert this other page to use default 2 to use the classes that I have used in just plain old default. If you want to before then, if you are bored, try yourself to convert the example default 2 to using these classes instead of having the code right inside of them. That would be a good exercise. In fact, maybe we'll do that as an activity next time. I don't know. Yes?
Did you want us to try this at all for the rocks, paper, scissors game?
Lab 3 doesn't require doing this. Lab 4 does require doing this. So the thing that is due this week, you don't need to create any custom classes. But the one that is due next week, you should create custom classes. All right. Okay, we'll see you in lab. As usual.